Okay, this page should look familiar to you because you clicked on this link right here. So I have some made up data in here. Aquarium temperature, dissolved O2 is staying pretty much the same. And I'm going to show you how to use a nomograph to come up with these saturation numbers. So remember, when we first went over this, we talked about dissolved O2 concentration in a natural setting. We would see the percentage of oxygen being close to 100% saturation as the temperature of the water changes. But in a lab setting, like the aquarium, where there's no extra oxygen being introduced because the filter was turned off, we're seeing oxygen levels stay level, and we're seeing saturation levels change. So that's what we're going to look at. Why does that happen? So the nomograph looks like this, and you're probably going to need to print this out, but you could, I don't know, use a straight edge of some kind straight off of your screen maybe. But what we're going to do is look at the temperature of the water and compare that to how much oxygen is in the water and see how saturated that is. So it's real simple. We're looking for 25 degrees on the nomograph and 8.1 on the nomograph. So the temperature's up here, here's 25, and here's about 8.1. And where this diagonal saturation line gets intersected by the ruler is the saturation. So we're at 25 and 8.1. So right about here is our saturation level. So it's just under 100%. So here's 90, here's 95. So it's about 96, 97% saturation. I guess I should have put, let's go with 96%. Well, this is made up data, so you guys are using the data that's on this packet itself and those pictures of the dissolved oxygen numbers. But that's it. So as the temperature goes down, since our dissolved oxygen is staying relatively the same at 8, you can see as the temperature goes down, let's go down to 20, but we're still at 8. Look at how the percent saturation drops. That's because cold water can hold more oxygen, right? Those oxygen molecules have less kinetic energy, so they're not able to evaporate quite as easily. So we're going to watch that happen as the temperature drops. Our saturation's going to go down, down, down. So what's that going to look like on a graph? So you guys will be doing this graph on Google Sheets, and I've linked a video on how to add a second y-axis like this, but this is generally what it's going to look like on Google Sheets. So I've already filled in my temperatures and dissolved oxygen. So if you did a best fit line of this, so each of these dots here, the black ones, that's the dissolved oxygen numbers that were filled in on the chart. So that's these. And then I have these orange dots in here. These are the percent saturation numbers. We can see again with the best fit line. As temperature increases, our saturation increases, even though the amount of oxygen is staying the same. And that's again because warm water can hold less oxygen, or cold water has a higher ability to hold more oxygen. So it's less saturated when it's cold with this much dissolved oxygen.